Good afternoon, ladies and gentlemen. Today I'll give you a few slides just to give some more hardware background. Carlos set a good stage in terms of what's hardware for wearable technologies. And I'll go a little bit beyond what Carlos said earlier today. I'm a startup guy. I have been in startup for last 15 years. One of my startup went IPO. One of the startup was acquired by a national semiconductor now, which is TI now. And this is a latest startup. I listed some of the awards that we got. I was happy to meet a lot of entrepreneurial people today. We had a booth outside. I was there for the booth for a short time. One of my engineers was there for most of the time. And I got really good questions, a lot of questions about hardware, what goes, what inside these wearable devices and so on. So I'll just give a gist of it. This is kind of setting stage for the Q&A session and the rest of the panel discussion. Just one slide regarding M-Cube. I don't want to bore you. I know many of you are already having iPads and computers open. You'll Google very quickly more than what I can speak about M-Cube. So M-Cube designs MEMS motion sensor. MEMS stands for micro electromechanical systems. These are real mechanical systems which are very, very tiny. They're all built inside a chip. So many times you can't imagine, but all your phones are today using MEMS sensors. There are 10 to 15 MEMS sensors inside every smartphone today. And M-Cube is in this same area. We are designing these sensors which go into smartphones. The sensors that we designed are accelerometers, e-compasses or magnetometers, and gyroscopes. And there is a whole list of sensors. Later on I have a slide about what other sensors get used in the wearable technology. M-Cube also designs value-added software that goes together with this. This app layer is very important. We want to enable as many customers in terms of doing the pre-work for them so that they can take the reference design, they can take the software, they just add a chassis or small reference board and go to production. This is what's happening in today's world. People go from concept to design to production within a couple of months. This is the market that you want to be in. I know many of you have entrepreneurial ambitions and you would like to do the same thing here. In terms of the markets, we are into consumer mobile markets, we are into wearables and IoT, and today's discussion mostly focused on wearables. IoT is much bigger than wearables. Obviously, every startup needs to have something disruptive. Our claim to fame is that we have this 3D single chip technology. Typically, MEMS sensors, most of those who have been around for several years, 10, 20 years, like ST, Bosch, they have been using two separate chips, one for MEMS chip, one for a CMOS chip, and they bond it together and make it work. M-Cube was one of the first ones who came up with this single chip technology, so we can make it very, very, very tiny. And people ask me, how tiny can it be? And we say it's the size of a grain of a sand. So it's that tiny. There is a common quote that we use. You want to make your wearables ubiquitous but invisible. So the sensor portion of it, we want to make it so small, so that shouldn't be a limitation. And today we'll go over what other wearables are getting used, but we are moving beyond watches. Watches was the starting point. Somebody talked about a ring earlier. Yesterday I was at a conference where a ring was presented. So these sensors that go inside the ring, they have to be absolutely tiny. So that's what we enable. And again, another claim to fame is we make world's smallest accelerometer. Accelerometer is a sensor that goes into every smart wear today, every wearable, whether it's a watch or Fitbit band and so on. So that's what M-Cube is about. Now let's talk about sensors used in wearables. So this is a little bit going beyond, I think, what Carlos talked about in terms of the hardware platform. Sensors are heart of everything that happens in the wearable space. And we can talk about whether there are 3 sensors, 5 sensors, 10 sensors. It's going to grow. It started the same way in smartphones. Originally there were 2, 3 sensors. Today there are 10 to 15 sensors. Each of the sensor is going to enable new application, and people are going to differentiate based on these applications. Today, smartphones are not about making a call. They are about differentiating in terms of giving new features. If a smartphone or a wearable gives you your heart rate, okay, that's well known today. But then on top of that, for those of you who are conscious of your sugar levels and so on, if you can monitor that the whole day, that's great. And if your physician can monitor that, even better. Again, that's the space that we are going into. We'll talk about cloud and other things. So these are some of the sensors that are very common. I just gave a little bit definition and what it means. For those of you who are not very familiar with this, accelerometer is a sensor that really measures acceleration based on Earth's gravity. Earth's gravity is, we call it 1g or 9.8 meter per second square, for those of you who still remember the physics. That's today used for step detection, drop, shake, tap detection. So these are most of the features that we use, and using these features now, pedometers are enabled, many other applications are enabled. This application, by the way, was popularized by this simple thing, portrait landscape, which today everybody takes for granted. In fact, the kids here probably wouldn't have seen a phone without that. But this was a new application, and that suddenly popularized accelerometers, and every smartphone had to have an accelerometer in it. Magnetometer was the next sensor that went in, which measures really direction with respect to Earth's north pole. And that together with the other sensors enables measuring, navigation. It's one step towards that. Together with the third sensor that goes in there, which is gyroscope, now you get all the what we call as the 9 degrees of freedom, which can essentially give your coordinates as you move along. So if you are in a closed space like this, there is no GPS here. But if I am moving here in this room, on the basis of these 3 sensors, you can track yourself. You can track exactly where you are. Now think about the applications. If you go into a shopping mall and you know exactly which shop you want to go to, that's enabled by these sensors. Or if somebody wants to give you a coupon as you walk into a shopping mall and say, okay, if you go to this store today, there is a 20% off. That would probably decide whether you go there or walk there or not. So these are the enablers for technologies. And then there is a pressure sensor. Again, if you walk up the stairs, the pressure sensors are so sensitive that it can detect that you are walking now up the stairs. Many of these are also used in health monitoring. Humidity sensor is used typically for context. All of these are going towards context detection as well. Whether you are sitting in a conference room, whether you are at a restaurant, whether you are exercising, all of those things. Temperature sensor is another one. IR sensor is typically used for now pulse rates and so on. So these are some of the sensors. It's not an exhaustive list. There are lot more sensors than these. This is one of the marketing slides. Some of you who are really interested in the business portion of it will really get excited about this. This is sensor market, by the way. This market is going from 11 billion just a couple of years ago to 22. It's doubling up in next few years. And the reason I show this slide is number of things. First, sensors are really the heart of all these wearables. Many people look at wearables more from feature point of view. Some of you look at it from software point of view. But sensors are the heart of it. If you understand sensors well, if you understand the capabilities of sensors, you can design applications around that. And if you think of these applications ahead of somebody else, then you'll be winners. If you are just following somebody else doing pedometer, then of course you are a follower there. Now this particular panel discussion is about wearable stack. So I put a very simple slide here that still gives you a gist of what's really involved in this stack. First thing is hardware. I already talked about sensors. Then there is a connectivity aspect of it. I think earlier in some session somebody asked whether it's going to be Wi-Fi, BLE or so on. So Bluetooth is very common, particularly because Bluetooth has this low energy standard, and that's something that you want to have as a wearable platform. Then MCUs, some type of processing. Again, there is a big competition in terms of getting it down to few microamps of power consumption per megahertz. And that's a benchmark. And there are some startups in that area who are just working on that technology. Power management is another area. You probably hear it on and off. You want your wearables to last in terms of your battery power for at least few days, if not for weeks or months. You don't need to be charging every 8 hours because that's going to soon lose your interest in that application. And displays are what makes it really nice to look at. And in the display market also there is a lot of innovation in terms of wearable displays. Then the next stack comes up is the software. There are, again, within software there are 4 or 5 layers. There is a driver layer, which is just talking between sensors, taking that data to the next level. Then there is firmware, there is OS, and then there are apps. So typically people talk about apps most of the time when they talk about sensors and wearables. Then there is cloud, which is now people are trying to get a grasp of it as to what they can do with this, because all of this data is coming up, it's going to get stored somewhere. And who needs to access this data? So today, most of the wearables, people are talking about accessing, meaning social networking aspect of it, in terms of, okay, how do I compete with my friend? How many steps is he taking? How many steps am I taking? Now, is this really of interest or not? Okay, that's up to people, but at least it got people excited. It's something more social these days. There is another aspect of it, which is big data analysis, and there's a lot of talk about it. I don't believe people have even today understood or really grasped what could be done with this big data. Again, I was at a conference just before coming here the last 2 days, and there was a lot of discussion on this one as to whether all this data is processable, first of all. If it gets loaded up there in the cloud, who's going to look at this data? Would physicians really like to monitor your heart rate for day after day after day? And they don't have time for this one. So there has to be this middle layer somewhere, software layer, which is going to post-process it for them or pre-process it for them and give it in a way that says, oh, today something drastically different happened on this person. So that's the middle layer that I think there is a lot of scope for those of you who are software-centric, or even on the hardware-centric side. The more the hardware can process and only upload that much less data to cloud, that's going to enable all these applications. So on the big data analysis, there is a lot of work to be done, both from application side as well as from the server, internet, every other side. Some of the popular wearables, I think many of you are using these today, so we don't have to talk much about these. Wristwatches, I think everybody knows these, all the features. Fitness wearables, every day new ones are coming up. It's always amazing to look at these. There are hats, again, using the same sensors that wristwatches use, but just a different gadget. Google Glasses, I think here in the Valley, we don't have to talk about it. Medical devices, there are interesting applications coming up. Always excites me that where people can use all these sensors. Social bands, similar things. Smart jewelry, I just happened to see one of these. Again, the form factor is what makes it really interesting to people. And mostly when we talk about wearables, we talk more about these sensor-based watches and monitoring and so on. But energy harvesting is another important field. If you don't want to charge your wearable every day, every week, then if you can generate energy yourself within that wearable, that's something of interest. This is more into academics today, but for 2 reasons. First of all, the energy that generated is still very minuscule. That's not enough to supply all these sensors. This is typically what's under the hood. We look at these smart watches and so on. We had one in the display here in the outside on our booth. So what's there inside these? There is a microcontroller or some processor, and then there are sensors, and depending on how many sensors these guys want to use, they could be accelerometers, compasses, gyroscopes, other sensors, humidity, pressure, temperature, and so on. There is a flash memory to load your apps and programs. There is a power, depending on how long people want to last this wearable battery. And then there is a mechanism which could look very sleek, like what you have seen from Microsoft and Apple and Samsung. Or it could be very simple that just makes it to work. And then LCD displays another portion of it. So if you want to go even beyond one level down, this is how simple it is. This is a tear down of this one. And every time somebody comes with a new wearable, whether it's Apple, Samsung, you can see, you can Google these tear downs and you see exactly which components who's using. In the technical world, it's of interest to us as to which sensors went in there and how do they compare and all that. So key requirements from hardware component side, power consumption is the biggest one in the wearable space particularly, because nobody wants to charge their wearable every day. Yeah. And to give you an idea of what power consumptions we are talking about nanoamps of power consumptions. So in the few days, a couple of years ago, when we talked in the mobile spaces, 5-10 microamps, people said, oh, that's same as 0 to us. Today when I talk to wearable guys, They say 200 nanoamps, that's a lot. Every nanoamp counts. So that's the difference. And the more these, whether it's a BLE, whether it's an MCU, whether it's sensor, the less power they consume, the longer these wearables are going to be lasting in terms of battery and as well as even their longevity use. Size is another one. I mentioned about this sand size or grain of sand. That's what is going to again enable it into different applications. Cost is the third one. These watches sell for a few $100s today, $100 to $300, but the BOM cost, the bill of material cost of these eventually is going to go down to sub $10. So most of the money to be made is in the system companies. The sensor companies, component companies are selling into millions and tens of millions. Physicians may not be as much tech savvy as some of you here. So that field is still open. Activity sleep tracking, again, that goes with most of the wearables today and people are using that. Context recognition, this is an upcoming field. People are working onto it. You see a lot of acquisitions in the recent time that have happened around that because this is a next area that's coming up. In the next year, 2 years, you will start seeing this. Gesture recognition with wearables is just coming up. There is a lot more scope to doing this. Social networking, games, information sharing is already there on today's machines. Inertial navigation is not there yet. It's in infancy. It's in the research world for the last 5 years. We believe in the next couple of years this will really come out. And energy harvesting is something which has really longer legs. It's probably going to be in the 3 to 5 years range. It's still in the academic world and it's coming up on the wearable side. So that's just to give you a gist for the rest of the discussions that we'll have at the panel time, and you can hold off your questions until I think this rest of the panel members speak. Thank you.
I'm John, and I work for a company called TalkRay. So I'm going to talk about how TalkRay is using wearables. So I'm a couple things. I'm a software engineer at TalkRay, and I'm also a Wearables GDE, which is Google Developer Expert. So Google has kind of these people out in the community who they deem experts in a particular technology. It was originally Google Glass, Google Developer Expert, and it shifted to Wearables when Android Wear launched. So a little bit about TalkRay. We're a mobile calling and texting app. We're really good for groups and focused on low bandwidth applications, places where you don't have a great cell signal or something. We want to be able to work in those areas. So it also means cheaper on the data costs, and also being low bandwidth helps us be really fast in our message sending and low latency for the audio. So I'm just going to go through kind of a little bit about TalkRay, and then talk about kind of how wearables play into that. And, I think that you need to understand a little bit about our app and our company before the wearables part makes sense. Whenever you do something with wearables, it really has to kind of fit into your product well, and you have to be able to present an experience that makes sense. And it's not just a matter of porting over the phone app to whatever it is, the watch or glass or something. You have to kind of think about what you're going to be giving the user. So yeah. Anyways, we're kind of focused on immigrant populations, travelers, international travelers especially, where calling is going to be expensive for them, so it makes a lot of sense to use an app like TalkRay. And also for group calling, which we know is a pain point for a lot of things. I'm sure a lot of people have used kind of conference calls, and the quality is not great. Like I, ran my own PBX for a number of years, and like whenever I would do a conference call, I was always embarrassed with like stuttering and things like that. So really happy with how we work for that. And for people who are sort of away from home, away from where they grew up, it's great to be able to call your family for free. So the company, just a little bit about us, we're a really small team. We have over 1 million daily active users, 30 years of calling every day on the service. We're all very focused on the product, which you kind of have to be with such a small team, but we all really love the product and really love to kind of talk about it. We've been called out as a Google top developer, featured a number of times in the Play Store. We're growing, we have great retention. We are actually really focused on India. It's kind of funny that I'm here because it's the market that we care actually the most about at Talkray. We're also hiring, so. So the technology stack that we use, our main platforms are Android and iOS, and we're working really hard on Windows and Windows Phone. I don't know where that's coming from. Working really hard on Windows and Windows Phone to get up to speed there, because I know that that's pretty important for especially India. I don't know if I'm stepping on something that keeps making noise. Anyways, we have a custom backend, and we were built from the ground up for mobile. We really, like I said before, really focused on the very low bandwidth applications. We want to work really well, even if it's on a 2 or 2.5G network. So now we can talk a little bit about wearables, and so last summer of 2013, I got the opportunity to get Glass, and I kind of talked to the founders, and I said, look, I think wearables are going to be really important in the next few years. I think it's going to be really hard for us to just jump onto that platform. We had spent a fair amount of time thinking through the user experience on mobile, how we were going to approach a lot of the problems that we had, and how we wanted to present things to users, that I knew that UX stuff was going to be probably a much bigger concern than the technology stack itself. So to me, it was less important about whether or not Glass itself succeeded or failed, and more about learning from Glass and learning about what sorts of things work, what sorts of things don't work on this new paradigm. And I sort of figured that Android Wear hadn't been announced yet, but it was pretty obvious that Glass had some big constraints in terms of how you can use it and how you interact with it. And I sort of figured that probably watches are going to be very similar in terms of the constraints that you have, and it might be a little bit of a different experience. But I think that at the time, my thinking was, look, if we can figure out how to make a good experience on Glass and learn, really, have a deep understanding of what works here, then whatever ends up being the next thing, we'll be prepared for. So one of the things that I did for Glass was oh, sure. I'll just talk loud for a second. What's that? Okay. Yeah, he's going to switch me back on. I'll just talk loud and switch it down. So one of the first things that I did was I built, one of our earlier apps was Tickle, push-to-talk kind of walkie-talkie app for phones. So I built a prototype for Glass for Tickle. And it was a really cool tech demo. You just kind of tap the thing and you start talking on somebody's phone, and then they can talk back to you. It works pretty well. There's some issues with when you're using a Bluetooth connection, you can't do UDP data, which is you want that for audio. So it wasn't something that we could easily productize, but it was kind of a fun experiment. And I did a lot of other experiments kind of on the side. I built a hearing aid for Glass that actually went through some medical testing trials. Didn't work out too well, but I made a GIF camera, which was fun. heart rate monitor. So basically, like if you're wearing a Bluetooth chest strap or like a Bluetooth-enabled heart rate watch, you can see your heart rate on glass. And I also built this kind of notification mirroring thing before Android Wear was announced. So that's kind of just some things to learn about glass and how it works, and kind of start thinking about, in terms of building for glass, like what sorts of experiences make sense. So that really prepared us for Android Wear, which I'm sure everybody's aware is a real consumer product. And because of this experience, we were able to release an Android Wear product or integration for our app. We launched it at Google I/O. We were featured by Google for it. And we focused on a lot of UX lessons that we learned. And so you can sort of read the stuff here, but I'll sort of take you through the thought process. Basically, like I said, we're a calling and texting app. So a lot of times during my use of Glass, I'd get messages in on Google Hangouts. So I'd be like off riding my bike, and my wife would send me a message like, "Hey, do you need a ride?" And say like, "No, I'm on my bike," and kind of keep going. It was really cool because like I didn't have to stop what I was doing. I could just respond and keep moving. What I noticed though was that I would always look at the screen when I was doing that, and it's dumb because like I'm just talking. I know what I'm saying, but what I was looking at was when you speak something to Glass like that, it's doing speech to text, and it's giving you the translation of what it thinks you're saying on the screen, so that if it figures something out wrong, you swipe and start over or whatever. But that's really distracting. Like if you're on your bicycle, if you're driving, you really don't want to be doing that because you're not focused on the thing that you're supposed to be doing. So that was like something that was in my head when we were looking at Android Wear. Another thing that was in my head was like just having to think about this stuff at all, like having to read the message in the first place when you're on the road. That was something that, from the first time I had Glass, like I was thinking about, it should be sort of enabling an experience where you really don't need to think about that message until you get to your destination. It would be a lot safer if people did that. So that was another thing that I kind of wanted to be able to address. The focus I think when we approached Android Wear was like, okay, let's be able to very quickly and easily respond to incoming texts. We also wanted it to be kind of a little contextual. We wanted to give people a little bit more than just a very simple canned thing. But we didn't want them like interacting very much at all. We didn't want them swiping through a bunch of choices. We didn't want them to have to think about what they were doing. So what we ended up with was basically, if you get a message in on TalkRay, you can see the message on your watch. It shows up as a notification. And you have basically 3 actions. One of the actions is kind of the default, just open it on the phone, right? Okay, so that's the last one, pretty obvious. The other 2 are a little different. The first one is we enable auto reply, and the auto reply is contextual. So if you're driving, you can hit that button, and it's just one button. It sends a message that says like, hey, I'm driving right now. I'll get back to you a little bit later. If I'm driving and people are starting to send me a lot of messages, like I'll hit that button, let them know that like, yeah, I'm not ignoring you, but like I can't talk right now. Like I can't read your messages unless you want me to get into a car accident. Which is helpful, like to be able to actually let them know that you're driving as opposed to just like busy. So we thought that was valuable. So we were able to use like Android actually just has activity recognition. There's an API for it. It's really, really easy to integrate. So we use that and can figure that out pretty easily. The other thing that we wanted to do was address this problem of being able to actually respond, like have a real response, but not needing to stare at the screen, which meant that speech to text is not really a good way to go because you can't like do that without showing the user what it is that they're saying. Because if you've ever used speech to text, like it can get things really, really wrong. and you don't necessarily want to hide that away. So what we decided was, like, we have an option in our app already that you can send voice messages. So you just record the message, and that's what gets sent. There's no translation involved. Like, the user, whoever's receiving it, actually just plays your voice talking. There's a microphone on these things, so it was pretty easy to just like pull in the code from the Android side, and it took maybe a half hour to get it running on the watch. So that's what we do. We just record your voice and then send it. And it's actually like it'll auto send, so you don't even have to think about when it ends. It just, it counts down 30 seconds. At the end of the 30 seconds, it automatically sends. If you want to send it sooner, you can just do a single tap, and that's it. So that was kind of like thinking about our application for Android Wear. And I think it sort of illustrates the approach. We didn't want to give everything. Like, we do a lot of other stuff in our app. We didn't do most of that for Android Wear. We focused on a couple really key experiences and went with those. Because the watch is not a phone, neither is glass. You're not going to sit there and spend a ton of time interacting with it. You want to have like really, really short interactions. You don't want to think about it too much. You just kind of want to get your information, maybe take some action and get out. And so that was, that's why we went with the really, really simple features that we went with. Down the road, I think that we'd like to probably extend that a little bit. I think that there's a little bit more that we could do, keeping it very simple, that might be compelling, and potentially some glassware for TalkRay. I think other platforms would also be good. Like I said, we're working on Windows and Windows Phone right now. So yeah, that's I guess that's my spiel.
Fairly low data rate and medium range type technology, and it's usually good for things like getting notifications and things like that. But when you actually want to do something, maybe like a chatting app, with voice on your watch, it may not be that good. The other technology that's often considered is wireless LAN or Wi-Fi, and the main drawback of using Wi-Fi on a wearable is that it consumes more power than other technologies like Bluetooth, for example. But on the plus side, it's orders of magnitude faster. And the last one that I think is useful for wearable devices is actually NFC. And as we can see from the iWatch, which Apple announced, they're actually using NFC to enable tap-to payment. But it can also be used for other interesting use cases like authentication or something like that. And going forward, I think we'll also see wearables that actually connect to the cellular network using GSM. That's highly desirable, but it's also using more power than any of the other technologies I mentioned. And some wearable devices now are actually including global positioning sensors for doing GPS. This would kind of enable more of a standalone wearable device that doesn't need to be tethered to your phone. So let's take a look at this is the new Samsung Galaxy Gear S smartwatch, which was announced a couple months ago. If you look at how it's designed, it's actually very close to what you would consider a smartphone today. Has quite a powerful processor. In fact, probably about 4 times more powerful than the original iPhone or Google Android G1 phone. And quite a bit of memory. And what you'll really see is that the battery is tiny, 300 milliamp hours. So to really make this thing work, every subsystem has to use as little power as possible. And many of the smartwatches today have similar features to this, although this one is a little bit unique because it has the GSM connectivity for the cellular network, and it also has a standalone GPS. So I imagine that the main use case for this type of smartwatch will be that you don't need to have it and use it in conjunction with your phone, which is nice for some applications, maybe for working out at the gym and you don't want to carry your phone, or running, or golfing, or something like that. So the first wireless technology that I'll talk about is Bluetooth Smart, which is also known as Bluetooth Low Energy. Bluetooth Smart is kind of the marketing name for it, but before that it was known as Bluetooth 4.1 and BLE. One of the most compelling things about BLE is that it's fairly low power. The peak current consumption is less than 15 milliamps, and the standby current consumption is quite a bit less. And it also has the ability to be able to connect quickly to a device, so it can kind of be asleep, and then on demand it can quickly connect to your smartphone, for example, to transfer data. The data rate is quite low, less than a megabit per second, and for some applications that's fine, but as smart wearable devices get smarter, the requirements for data will go up. Bluetooth operates in the 2.4 gigahertz RF spectrum, which is the same as Wi-Fi and the same as your microwave oven at home. And in order to allow multiple Bluetooth devices to coexist, they use a technology called frequency hopping spread spectrum, where Bluetooth device jumps between many small narrow channels throughout the band. And today, iOS and Android both support APIs for using BLE. So you can connect to, actually, even if you have a Fitbit, you can write an app on Android to find the device and connect to it. So those kind of things exist today. One of the new features for Android 5.0 Lollipop, which was released a couple days ago, is that they actually support the Bluetooth Smart peripheral role, where your watch can actually act like a device. And the other nice thing about BLE is that it can be used to advertise presence to other nearby devices. This is similar to Apple's iBeacon concept. Another interesting wireless technology for wearables is Wi-Fi. Traditionally, this has not been used that much because of the power consumption. But Wi-Fi does offer some neat functionality that can improve the user experience on wearable device. Like, for example, I have one of the original Samsung Galaxy Gear watches here, and one of the features it has is that you can actually take a picture with it, and then it'll transfer the picture to your phone. But transferring the picture takes quite a while. So not only is it bad from a user experience perspective, but also it means that my watch will be, on with the screen on, consuming power the whole time while it's transferring the file. So while Bluetooth may be lower power in and of itself, it can actually cause the watch to waste more power, waiting for this file to transfer. So this is where you can actually consider using a technology like Wi-Fi to improve the transfer rate. And to do that, you would typically use something like this Wi-Fi Direct, which is also known as Wi-Fi peer-to-peer. And this is where you can have a device operating in one device, like maybe your phone, will operate in a group owner role, where it's basically a Wi-Fi access point. And then your watch would actually operate as a group client and be able to transfer data directly to the phone. Similar to Bluetooth, Wi-Fi also operates in the 2.4 gigahertz band. So it's quite common for Wi-Fi and Bluetooth to interfere with each other. And this is a constant challenge for device manufacturers, and it manifests itself as headaches for the user. For example, you want to watch YouTube, you're streaming it over Wi-Fi, listening to it on your Bluetooth headset, and the audio is popping or something like that. That's usually because Wi-Fi and Bluetooth are are kind of getting in the way of each other. And this becomes an even bigger challenge when you have a small device like a wearable where the antennas may be very close to each other. The Wi-Fi typically operates in a power-saving mode where it's asleep most of the time. And in a mode like that, on average, Wi-Fi may use less than a milliamp. But when you wake up to actually do transfer data, it can use quite a bit more current. Some of the higher speed devices can use more than 100 milliamps on transmit. So for something like a watch or a wearable, that presents a challenge in the battery subsystem. But on the good side, you can actually get very high data rate. The latest 802.11ac Wi-Fi devices can operate up to 300 megabits per second with a single stream. And these are the devices that are in smartphones, but there's nothing that prevents those devices from operating inside of a wearable as well. And even in the older Wi-Fi legacy devices like 802.11g and 802.11n, the effective data throughput that you can get is still in the multiple tens of megabits per second. And there are already APIs for writing software using Wi-Fi Direct in Android and Windows 8. Apple has something that they call AirDrop, which has similar functionality, but it's not at all Wi-Fi Direct and not compatible. The third technology is near-field communication. This is typically used for tap to pay and things like that. It's only a point-to-point communication, not really a network like Wi-Fi or Bluetooth. And in this case, the radio frequency is at a much lower frequency. It's at 13.56 megahertz, so quite low frequency, which requires a big antenna. The power consumption is similar to Bluetooth Smart, although if you have like a passive Bluetooth tag and you tap it, then your device is actually supplying power to the tag, and then it will use more current. But the data rate is very slow, 424 kilobits per second, so about less than half of Bluetooth Smart. And the maximum distance is only around 20 centimeters, which is probably good for the type of applications that NFC is used for. So somebody can't read your credit card just by walking next to you. And there are two modes that NFC can operate in. One is a passive mode where a device like a tag is actually not powered at all. There's no battery. You just tap on it, and your device that you tap on it with transfers energy, generates the electromagnetic field, and then the passive tag actually modulates that field. And in the case of an active communication, both the initiator and the target are powered. So today, most of the wearables that we see are using Bluetooth LE. And overall, this is really a compromise. Like I mentioned, it's low power, but at the expense of throughput. And when you start to consider some of the use cases, having the low throughput can actually lead to an overall increase in the system power if the device needs to stay awake longer in order to transfer the data. So there are a few wearables, like the Google Glass, which actually do use Wi-Fi. I don't know, is it heating up your head? No. There, okay. But in that case, it actually does communicate through Wi-Fi. Probably because, I don't know, maybe Glass, they actually transfer more data. Not really sure why they chose to use Wi-Fi. But one good thing about using Wi-Fi is that you can also connect to a regular access point and get access directly to the internet. So you don't need to have another device like a phone involved. And then there's some newer watches like the Apple iWatch, which has all three. In fact, all three of those wireless technologies are in a single piece of silicon that Broadcom made. And it includes the Wi-Fi, Bluetooth, NFC, and NFC radios. So I believe that Apple will use the NFC for mobile payment, but I don't know if they have any other use for it as well. It might be kind of cool to unlock your house door with it or something. And then, you know, like this new Samsung watch that I showed earlier, that's actually has GSM connectivity. So that's great when you're hiking, you know, and at least you might have some cell access, but you don't have any Wi-Fi or anything else around. And I kind of expect that trend to increase going forward, at least for a subset of the wearables. You know, if people are willing to pay probably extra every month to their carrier for the privilege of having GSM. So if we look at some of the software for the wearable stack, we can see that the Bluetooth and BLE is kind of at the bottom of the stack, and apps kind of talk between the host and the wearable without ever knowing really that the data is going across a wireless transport. So that actually provides the opportunity to use any kind of wireless transport without having to change the apps, which is nice. But it also means that many developers who are writing these kind of apps, they don't really understand what's going on at the lower level, and that may have negative impacts in terms of the performance or the battery life of your device. So here we have just a brief example of how to use the Google Glass, Android Wear SDK to send a message to a watch, and it's quite simple to write the code for it, but underneath all that in the stack, there's actually a lot going on. So I think if application developers understand the wireless technologies better, they can write apps that are more efficient, more responsive, and better conserving of the battery on both the wearable and the phone. I was hiking a couple weeks ago up north, and I had my Moto smartwatch, and I was using an app provided by Google for keeping track of where I was going. It wasn't really for navigation, but just so I could find my way home. And within 2 hours, my watch was completely dead. And luckily my phone still had power, so I did find my way home. But it just shows you how a poorly written app can really kill the battery life. So hopefully Google will find a way to you know, improve that. So I think software has a large impact on you know, how long you can use your wearable for, and as software developers we need to keep that in mind. Now I kind of wanted to show you an example of this is a Broadcom Bluetooth LE kit that you can buy for $20, and it's actually a development kit that includes the MEMS sensor and the BLE and a small coin cell battery. And there's actually a SDK available, so you can actually write the firmware inside of here to create your own application. And they also provide source code for the app side for iOS and Android. So this is kind of a really neat way for very little amount of money to kind of do something neat. And out of the box, they have it designed as like a key fob. And you can do things like find your keys, you know, that's one of the applications that they thought of, but I kind of had my own idea. I was thinking about using this to you know, try to find a way. One thing I'd like to know is if I'd like my house to kind of know if I'm home, because I have a lot of you know, connected devices that I connected up in my house for different things like lights and door lock and stuff like that. And it would be really neat if my door knew, okay, don't automatically lock because she's standing in the driveway or something like that. And I think BLE and these kind of devices that can operate a long time on a single coin cell battery can help to enable those sort of things. So I brought a tablet here. It's and I just wanted to show the application that that Broadcom provided with the device, so you can just see what it does out of the box. Let's see if I can connect it in here. I hope I don't have too much Bluetooth Wi-Fi interference. Yeah, so it's actually connected, and you can see there's an accelerometer, compass, and also some gyroscopes, and then it gets things like temperature, pressure, and humidity. So these are all the things you were talking about. And here it is, wirelessly going, using BLE from this device onto my tablet, and same also works for. But the one thing that I saw that was quite alarming is that when you're sitting here playing with this device and it's on all the time, you can actually see the battery percentage drop in real time. And that's mostly because it's streaming data, probably at a quite high data rate. But I think if you use this as a tag, just for like a beacon or something like that, it probably can last 6 months or a year on a coin cell. So I've been busy recently in my new job because the L release of Android just got released, so we're all porting that. But when I have some time, I want to go and really play around with this and see what I can do. And then there's a similar kit that Broadcom has for Wi-Fi. It's a little bit more expensive, like $99. But it's also neat because it abstracts a lot of the difficulty of doing the wireless communication into a prepackaged hardware module. So if you look at the diagram on the, let's see, that's left. On the left, this shows kind of the software stack for communications inside of a smartphone. So the only thing that's really done inside of the Wi-Fi module is maintaining the Wi-Fi link and doing the air interface over the physical layer. If you look towards Wicked, the new design and what we can use for wearables, all of the networking stack has actually been moved over into the Wi-Fi module. And the main reason to do that, well, there's a few reasons, but one is that it makes it easier for people to develop an application, concentrate on the stuff that they know and not have to learn all the networking and Wi-Fi stuff. And second thing is that it can reduce power, because now you have a low power, sort of low speed microcontroller handling all the Wi-Fi and TCP/IP networking. And meanwhile, the main processor can remain asleep. So you can do things like maintain your association with a Wi-Fi access point. You could do things like keeping TCP sessions alive, all within this microcontroller without having to keep your big processor waking up all the time to do those maintenance tasks. And this is just a list. I guess after the conference, the slides will be made available, and for people that are interested, they can go and take a look in more detail at some of the links. So that's all I have. Thank you.
So should we open this up for question Q&A? All right.
Hi, thanks for the informative presentations. I have a common question to three of you. So these days, a lot of companies, startups or mobile developers are trying to come out with indoor positioning applications using the BLE, right? Since the GPS is not so accurate indoors. So what do you think are some of the challenges with BLE technology, and any sort of solutions do you think you think that can come into market pretty soon?
So I can take that question because this is very related to sensors as much as it is related to the application side. The accuracy required by sensors is quite high, and there is some parameter called as drift of the sensor, particularly gyroscope, that tends to drift over time, and so you lose the accuracy. So people are targeting today accuracies in the range of about 1 meter. Don't try to do anything more aggressive than that. The whole goal for the last few years in indoor navigations was, if you are walking to a shopping aisle, you at least go into the right aisle. So that's about 1 meter kind of accuracy. And it's a challenge. We are getting there now with all the sensors.
All right, we have one right here at the bottom.
So just curious, what is the role of RFID in wearables? Is there any place for RFID at all, or?
I think RFID is similar to NFC, right? And it's a similar technology underlying both. So I guess it could use RFID, but I think NFC is kind of probably more popular these days.
So is there any advantage to NFC over RFID, or?
Well, I think with NFC there's some kind of security that's on top of it as well. I think RFID is completely insecure. So.
Thanks.
But what about the range though? NFC range is pretty small.
NFC range is very small, yeah. And I'm not too sure on the range for RFID. But I think it's the same underlying radio technology, like the same frequency and things like that. Maybe different in range due to the difference in power level, but they're very similar.
Yeah. So today we heard a lot about how wearable technologies will make a big difference in healthcare, but somebody just alluded to the fact that energy harvesting could be a good. Could somebody elaborate on that a little bit more? How this will make a difference?
This is a long discussion, but there are 2 or 3 different types of technologies. There is piezo resistivity based technologies. So as you move, your clothes are going to move, and that's going to generate electricity. It's very tiny. It's in microamps level or nanoamps level. Question is, are there going to be enough number of sensors over your clothes that it can generate and power something? So that's one area. The other areas of, for example, people are thinking about putting something in your shoes. As you walk, you can generate energy based on that. So there are multiple different approaches as to where you can put it and generate effectively some area, some energy, mostly into academic area because people are just trying to develop these technologies. None of these have shown up into any wearable gadgets yet, but I would expect that in the next 2 to 3 years, something will start showing up. Same thing in terms of, it's not so much related to the wearables on the clothes side, but there is technology which is at very low solar level, you can generate some energy. So that's also in operation now.
All right, we have another question at the back wall to their left.
Hi, my question is more on power consumption side. So first part is, what is the major contributor, MEMS part or the CMOS part in the power consumption? And second part of question is, until now the technology node trend was going from 90 to 40 to 20 at smaller nodes, but one of the TSMC foundry has gone back and announced 40 nanometer ultra low power for wearables and IoT. So what do you see as a trend, as a technology node being used for wearable in near future and above the ahead future?
Okay, that's a good question. There are 2-3 parts of that question in terms of which component consumes most energy. Not all MEMS sensors consume same amount of energy. Accelerometers consume the least amount of energy, and fortunately, I mean, these are the ones which are most popularly used in all the smartwatches and so on. They consume energy as low as less than 1 microamp today in the operational mode. Gyroscope, on the other hand, consumes somewhere in the range of 3 to 5 milliamps. That's why at TimeCube, one of the products that we brought up was a very low power 9 degrees of freedom part. So those are the alternatives there. As far as the MCU is concerned, this question that you asked about technology node, that's where it plays in because MCUs consume a lot of energy too. And this TSMC node that you talked about, that's the direction that companies are going. There is another direction which is sub-threshold operation of devices that allows you to operate at really low power. And then there are some in-between layers which is not exactly sub-threshold, not exactly full inversion, but somewhere in between, and a lot of companies are trying to operate in that area. So there is a optimization on the MCU side, there is optimization on the BLE side. We had a long presentation on that one. BLE I think is more optimized for power consumption, and there is optimization on the sensor side.
Yeah, and I'd like to mention something on the silicon side of that too. Like, for example, more than 20 years ago when I got involved in semiconductors, nobody even cared about the static power consumption of a chip because, it was easier to just assume that all the current happens when the transistors are switching, right? So we just assume that static power consumption is basically zero for CMOS. But nowadays, with the small technologies, as it gets smaller, the leakage current actually increases, and that becomes the dominating factor. You know, your device might be kind of not doing much all the time, and if the leakage is high, that will chew your battery up. It's not only about you know, the switching current. So as the geometry gets smaller, the leakage goes up, and there's, you know, ways to deal with that. But I think that in general, if you can stay on a sort of older node and just concentrate on improving the power, that might be a win. So at the expense of area. So.
I have a question. Can I ask, please? Okay. So this is not related to any, I mean, in terms of energy or stuff, but I just wanted to know, like, when the pedometers and all those stuff, like Fitbit, Shine, all these things, half of the time they don't give you the accurate results. Let's say if I'm wearing it on my right hand, I mean the day when I wear it on my right hand, it says target is met. On the left hand, if I wear it, when I come back home, it's like, okay, you have to walk for 30 minutes to meet your target. So is there something which, you know, technology persons are thinking ahead of time and making sure that how these kind of gaps can be filled in future?
Sure. Not all pedometers are made equal.
I believe me, I tried everything in the market. Fitbit, Shine, Nike watch.
I completely believe you, because we tried to calibrate out different pedometers available in the market, the ones available on the smartphones, the ones which are separately sold for even $50 in that range. And the accuracy on pedometer varies from anywhere from about 60% to about 97-98%. Okay. And the reason for that is, as I indicated, all of these are based on this sensor called accelerometer. And accelerometer is measuring acceleration, but depending on where you are wearing it and where your feet is, how much of that energy is translating to that accelerometer, that's what is going to make some portion of on this and process this data. So those two make up for the inaccuracies typically in all these applications.
So why don't people create a pedometer which actually is worn on either shoe or legs instead of wearing them in the watch, I mean in the hands and stuff? I know Shine has come up with some crazy idea that it has you can wear it as a pendant, or you can, you know, hang it anywhere you want, but it doesn't give the accurate results as well. So, I mean, I definitely understand that there is lots of improvement scope. I hope technology person take this moving forward.
You know, to just digress a little bit, my mother is a diabetic, and she has 2 blood testing machines, and she'll test with one, 220. She says this machine is bad. She'll test with another one. She says 130, okay, this is better. So, I mean, this is something that's been around for like 100 years. So I think with pedometers, we have another 100 years to go before we'll get to some kind of accuracy. Anyway, next question to your left, please.
I've got a question for John, as someone who thinks deeply about interactive design as well as the visual design aspects of these sensors. Where do you see augmented reality going, given that we've spoken about Google Glass as being an intermediate step to getting to that final form factor? Is there any radical technology that you see on the horizon that might influence the next form factor of the Google Glasses being the next, you know, or whatever Google Glass becomes? Where do you see that going?
Sure. So I'm not sure that Glass itself is going in that direction. I think that they've actually explicitly stayed away from augmented reality applications. Although there are, you know, a number of people doing augmented reality stuff. You know, there are some kind of targeted scenarios where that makes sense, especially in industry. I think that there are other smart glass solutions that are a little bit better suited towards AR stuff, like the Epson Moverio and the Aura one that just got launched on Kickstarter recently. There's a few other smart glass that are a lot more geared towards AR applications. In terms of glass, there are some SDKs, like Mateo has one, and I think there's a couple others that allow you to do some basic AR type stuff. The experience on glass is a little different though. Like typically you will take a video and then you'll overlay your stuff on that video, as opposed to overlaying it on reality. Whereas, you know, the ones like Epson, where they're in your direct line of sight, they can actually just sort of start overlaying stuff on reality. I think that, at least for glass, it's pretty difficult to do AR. It's a single screen. It's really not fun to stare at the glass screen for more than a few seconds at a time. It's really kind of geared towards those really short interactions. So I don't think that that's where glass is going, but I think that there are some other smart glass products that are doing those sorts of things, and I think that definitely, probably two places that we'll start seeing them. First is industry. So there's like kind of manufacturing and medical applications that sort of are starting to roll out now. Some with glass, some with other products for those AR experiences. And I think there's also a company doing like a gaming AR glass, which looks really interesting. So I think probably games is another area that we might start seeing that. And then I think like once they get established, it makes more sense to then move into the consumer space.
All right.
So at one point in time, there's a lot of talk about wireless charging. So how closely is that industry working with wearables? Inductive charging, yeah.
I don't know in too many details about that, but I do know that for wireless charging, there's at least 3 different and competing standards, and I think that's the first barrier to getting it widely accepted. I mean, the Moto watch actually has a wireless charging, and it's better than having to. The Samsung watch has this crazy contraption that you clamp the watch in and then plug it into USB. So I definitely think that wireless charging is nice, but I don't really want to have 3 wireless charging mats on my table at home. So I think the standards need to get ironed out first. And this is actually a reason why if you look at some of the Samsung phones, you can actually buy a wireless charging cover for the back and just put it on yourself. But the reason why they don't make it, I think why they don't just sell it with that is because there's too many different standards throughout the world. So I think that's something that needs to be addressed.
Alrighty, we have another question here.
With these wearables, a lot of personal information is being transmitted either over Wi-Fi or over BLE to either a smartphone or the nearest Wi-Fi hotspot. So how secure are these channels and how these privacy concerns are being addressed?
Well, I think Bluetooth itself is, provides a level of security. Wi-Fi has quite good security if you use the modern encryption protocols, and I think that isn't where you should be concerned. I'd be more concerned with who's getting my data after it leaves my Wi-Fi network. I think that's it's going to companies like Fitbit and Google and Microsoft and everybody. So it's really what are they going to do with it?
I think for like kind of at least the Android ones like the watch and glass, the Bluetooth connections are encrypted. That's not necessarily true for peripherals. So like if you have some random pedometer, it may or may not be encrypted. The heart rate monitors may or may not be encrypted. So like it is possible to sniff some of those transmissions.
Yeah, and it is actually possible. I was reading about this last night. Somebody wrote a pretty neat little app that they run on their Raspberry Pi that can actually sniff out the Google Glass on their network and crack the Wi-Fi enough to be able to kick them off of the network. So if you want to, if you're afraid about people with Google Glass, spying on you or something, you can install that at home.
Or you don't want me checking my email while I'm at your house.
Right, we have a couple more minutes for maybe a question or two if anybody has any questions. Nobody?
Okay, cool.
Okay, there's one here.
Speaking of wearables in biometrics, how invasive are these sensors to someone who's sensitive, like an expectant woman, a pregnant woman? If she wears a device like this, how sensitive is it to health, from health point of view? Is there any implication at all for someone who doesn't know anything about sensors?
Yeah, so Fortunately, in United States, FDA sort of has an approval layer, and there are 3 layers: class 1, class 2, class 3. So unless the device is something like a pedometer, which is not going to do anything to your health, I mean, FDA doesn't interfere into that approval process. But if there is anything that interferes with your body, then you need FDA approval, and these guys are very diligent. They're also bureaucratic, it takes a long time, but essentially it is to the safety of common people.
But
I think these come under class 1A classification now, so they don't need approval or something like that.
Right, so there's like a lot of heart rate monitors and pedometers, like those sorts of sensors that they say are for entertainment purposes. So like you probably don't want to rely on a consumer heart rate monitor if you actually have like a heart condition. You probably want to get something from your doctor that's a little bit more reliable. They're good for like kind of getting a general sense of where you're going, and there's, you know, some are better than others. I don't think that they're going to, you know, like you said, impact your health in a negative.
There is no health impact on any of the known variables at this point, because most of these are in a class that doesn't fall into anything invasive.
So this is the first that I heard. We were talking about these things as fitness gadgets, but you said these are entertainment. So should these be classified as entertainment gadgets rather than fitness gadgets?
So personally, I think, you know, like you brought up earlier, there's a pretty wide range if you get different pedometers about what the readings are, right? So they're not like 100% accurate. I think that they're really good to get a starting point. You know, if you don't wear any pedometer, you have no idea how many steps you're taking in a day. You don't necessarily know how far you've walked. You start getting that data, even if it's like not 100% accurate, and you can start getting a sense of how much you're doing. So I think that it's good to start getting that sense, to start measuring and seeing, like, you know, if you're really trying to watch your weight, or you're looking at like the things that you're eating and tracking those things. It starts, you know, to get into that mode of thinking about it a little bit more, and that helps you to sort of take steps to say, like, oh, well, I'm eating 3 hamburgers a day, and I probably want to lose some weight, and so maybe 2 hamburgers a day is better. You know, those sorts of things where you kind of have to start getting some data before you can make changes effectively. Otherwise, if you're not measuring, like, it's a lot harder, I think, to have a good outcome.
I think he is a real geek who thinks all the pedometer data is entertainment.
you know, that's probably right. I have an LG G3 which has got a software called LG Health. So, you know, you just put it in your pocket, you walk, and it counts the number of steps and all that stuff. One day I go out for a walk at lunch, I leave my phone back at my desk. That day I'm the unfittest person on the planet. So I agree. It's at least at this stage, it's more entertainment than has real health value.
Sort of. I think you know, Google Fit just launched recently, and you know, they have it on the watch, and I think that there's some really interesting things going on there, where it is passively figuring out what sort of activity you're doing, tracking how long you do that activity for, so you can start to get like a rough sense of how many calories you're burning in a day. If you're counting calories, that's really helpful. So, you know, I think that there's some uses. It's not necessarily the best data source, but I think it, you know, it gets you something that you didn't have before. At least you now have some sense of where you are.
I would like to thank all our panelists. I'll call Deepak on stage to give away the certificate of appreciation. Please, Deepak.
All right, give it up for our panelists. Mr. Sanjay Bhandari, John Haig, and Howard Harty.
John. Howard. Thanks, Deepak.